Okay, example 3, asking the square of a number is subtracted from the number. Can the difference be positive? So if we let n represent that number, and then its a square is n squared, right? That k represents the difference, and then basically the question is asking, oh, if we use the n squared as be subtracted from the n minus n squared equals the difference. If we have to make the k greater than 0, and then can we solve for n, right? So basically that's the question you're asking for. So it's kind of indirect. What we're trying to do is put them into this kind of equation and then observe what kind of a k can make this equation have real solutions. Okay, so then it's really depending on the discriminant. Okay, so go ahead, look at this equation. So a equals 1, b equals -1, and c equals k. So plugging into this discriminant, b squared minus 4ac, so we got a -1 squared is still 1, then minus 4a, which is 1, and c, which is k, so we should get 1 minus 4k greater than 0, and then just plus 4k on both sides, and then divide. Just you can easily solve that. The k should be less than equal to 1 over 4. Now, what does that mean? That means when the k is less than equal to 1 over 4. Now, don't forget, the k must be positive. Now, that's determined in the first place. They must have a positive difference. So, and then as long as we as long as we can have the k in between 0, so which means it has to be positive, and less than 1 over 4, and then we can have a solution for the n, right? So since we have a solution for the n, and that means it is possible, right, for a number that its a square being subtracted from itself, getting a positive difference. Okay, and then if you want to look at it to check your understanding, I can show you the solution is right here. So it's very similar. You still just look at this question, right? Sorry, it's right here. So the question says a number is subtracted from its a square. Can the difference be negative? So basically, it's kind of opposite. So we just make the difference equals k, and this time the k must be negative. So we still solve this equation to see, oh, the k must be greater than -1 over 4, right? So now this time the question is a little bit different. It's a square minus n, right? Because a number is subtracted from its square, so it just reverse this. So then you can see that when you solve the discriminant, so you end up getting the k must be greater than -1 over 4. And since the k has to be negative, and it's greater than -1 over 4, and then it's always going to be negative. So then that means as long as the k is more than -1 over 4, and then if you increase, and then the k is gonna getting actually its absolute value getting smaller, and then eventually reach the 0, but it cannot be 0 because the k has to be negative. So that means the k must be in the range of -1 over 4 and 0. And in that case, this equation has real solutions. So that means we can find the number of n which make this difference being negative. So the answer to this question is yes. We can have the difference be negative.